So dear students, this session we are going to study singular value decomposition and very important decomposition, right? This is very useful in image compression and data reduction in machine learning. Okay, very important concept. First definition. So what is singular value decomposition, right? Suppose A be any rectangular matrix of order m by n. Then there are two orthogonal matrices U and V and a diagonal matrix sigma such that A can be written as U into sigma into V transpose. So just like decomposition of matrices using orthogonal transformation. So this is singular value decomposition, right? So here what is U? The columns of U are eigenvectors of A into A transpose. Okay, what is U here? The columns of U are eigenvectors of A into A transpose. What about V? V is columns of eigenvectors of A transpose A. So there are a lot of difference between A into A transpose and A transpose into A. Then what is sigma? Sigma is diagonal elements. The diagonal elements of sigma are singular values. Singular values. Okay. So what is singular value? Simply root of eigenvalue. So what is singular value? Root of eigenvalue. So three things are very important. So we can write here a rectangular matrix. We can write a rectangular matrix in two orthogonal matrices U and V and a diagonal matrix sigma. So what is U? Simply eigenvectors consist of eigenvectors of A into N transpose and V is eigenvectors of A transpose A. What is sigma? The diagonal elements of sigma are singular values, not eigenvalues. So this is very important point here. The diagonal elements of sigma are singular values. So what is singular values? Simply square root of eigenvalue. Okay. Right. Now procedure to find singular value decomposition. So first step, construct the matrix U by finding the normalized eigenvectors of A into A transpose. Okay. A into A transpose. Step 2. Construct the matrix V by finding normalized eigenvectors of A transpose A. Step 3. Find the singular values sigma by using the formula sigma equal to root of lambda. What is lambda? Eigenvalue. Okay. Fourth step. Construct the matrix sigma by replacing the eigenvalues by sigma. Okay. So finally write A equal to U sigma B transpose. Right. Now example. So here we are going to discuss only one example. Find the singular value decomposition of matrix A 3, 2, 2, 2, 3, minus 2. So here we have 2 by 3 matrix. Okay, it is a rectangular matrix, not a square matrix. But in the case of orthogonal transformation, diagonalization problem, we studied only symmetric square matrix, which is symmetric only. But here it is rectangular matrix, right? Now we are going to factorize a rectangular matrix. So what is our first step? We have to construct matrix U. What is matrix U? We have to construct matrix U. What is matrix U? Normalized eigenvectors of A into A transpose. So find A into A transpose first. So first write the matrix of A. What is A transpose? Simply change rows into column into rows of A matrix. So 3, 2, 2, 2, 3, minus 2. Now multiply these two matrices. So this is 2 by 3 matrix, this is 3 by 2 matrix. The resultant matrix is 2 by 2 matrix. Okay, right? So what is A transpose? After simplification, we get 17, 8, 8, 17, right? Okay. Now the characteristic equation of A transpose, right? The characteristic equation. What is characteristic equation form? Lambda square minus d1 lambda plus d2 equal to 0. What is d1 here? Sum of diagonal elements. 17 plus 17 equal to 32, 34. What is d2? Determinant of A transpose. So what is its determinant value? After simplification, 225. Therefore, the characteristic equation is lambda square minus 34 lambda plus 225 equal to 0. After factorization, we get lambda minus 9, lambda minus 25. Right? Therefore, the eigenvalues are 9 and 25. Arrange like this order. Okay, the highest value and then lowest value. Right in descending order. Okay, 25, 9. Okay, the eigenvalues of A transpose are 25, 9. Now we are going to find eigenvectors. So what is the formula for eigenvector? I mean eigenvector A transpose minus lambda I into x equal to 0. Okay, what is A transpose? This matrix. This matrix A, sorry, A transpose is this matrix, right? Now subtract minus lambda in the diagonal, right? Likewise. What is x? It is a two by one column matrix. Okay, it is a column matrix. So put x1, x2 equal to 0, 0, right? Now what is our first eigenvalue? Lambda equal to 25. Put lambda equal to 25 here. If you put like this, okay, 17 minus 25 become minus 8, right? 8, 8. Again, 17 minus 25 is minus 8. Now multiply these two matrices. What happened? We get two equation. Likewise, minus 8 into x1 plus 8 into x2 equal to 0. We get another equation 8 into x1 minus 8 into x2 equal to 0. If we simplify both the equation, we both are same, right? Represent the same, right? So choose any one equation. So here I am choosing second equation, 8x1 minus 8x2 equal to 0. Put x1 equal to 1. We can take any value. If you put x1 equal to 1, what about x2? That is also 1. Therefore, the eigenvector is x1 equal to 1, 1. But we need normalized eigenvector. How you find a normalized eigenvector? Simply take the modulus. That means square root of 1 square plus 1 square is, that is root 2. They would same root 2 by the second number. So we get 1 by root 2, 1 by root 2. So this is first eigenvector. To find second eigenvector, the given matrix is, I mean the A transpose is symmetric matrix, right? See here, symmetric matrix. Okay. With respect to diagonal, all the elements are equal. If you change row into column, column into row, both are same. So it is a symmetric matrix. So if the matrix is symmetric, then the eigenvectors are orthogonal to each other. So x1 equal to 1 by root 2, x1 equal to 1, 1. To find x2, take this as AB. It must satisfy this orthogonal condition, right? What is x1? 1, 1 transpose AB. Just to multiply them, 1 into A plus B equal to 0. We have only one equation. So take any value for put A equal to 1, we get B equal to minus 1. Therefore, x2 equal to 1 minus 1, right? Its normalized eigenvector is 1 by root 2 minus 1 by root 2, right? Root 2 is due to modulus. If you take modulus for this vector, square root of 1 square is 1, minus 1 square is 1. So 1 plus 1 become 2, root 2. So divide the each element by root 2. So 1 by root 2 minus 1 by root 2. Now what is U here? U is simply arrangement of eigenvectors. What is first eigenvectors here? First normalized eigenvector is 1 by root 2, 1 by root 2. Put 1 by root 2, 1 by root 2. What about second eigenvector? 1 by root 2 minus 1 by root 2. Put here. So this is the way to find U. Okay. Right now we are going to find V. Okay. How you find V? Simply A transpose A. Eigenvector, normalized eigenvectors of A transpose A. So first to find A, write A transpose, then write A. Now multiply these two matrices. So now this order is 3 by 2. This is 2 by 3 matrices. If we multiply these two matrices, we get a 3 by 3 matrices. In previous case, A transpose, we get 2 by 2 matrix. But here, A transpose A, we get a 3 by 3 matrices. Right now, we are going to find eigenvalue, eigenvector for the same matrix. Okay. So again, so it is a 3 by 3 matrix. The characteristic equation is lambda cube minus d1 lambda square plus d2 lambda minus d3 equal to 0. So what is d1? Diagonal, sum of diagonal elements. 13 plus 13 plus 8 equal to 34. What is d2? Sum of minus of uh, diagonal elements of A transpose A. Okay, so find the first minor. We get 13 minus 2, 8. Okay, similarly, if we leave the second 13 here, we get 13, 2, 2, 8. Similarly, for the last element, we get 13, 12, 12, 13. After simplification, d2 equal to 25. Okay, similarly, d3. What is d3? Determinant of A transpose A, that is equal to 0. If we simplify this, we get 0. Okay. So what is our characteristic equation? Lambda cube minus 34 lambda square plus 25 lambda equal to 0. Right? There is no constant term. Okay. So we can easily factorize this. So here, synthetic division is not necessary. Okay. Because there is no constant term. So we can easily take lambda as a constant, a common factor, lambda. So after simplification, we get lambda minus 9, lambda minus 25 equal to 0. Therefore, the eigenvalues are arranged in this order. Largest number to smallest number, 25, 9, 0. Okay. Now we are going to find eigenvector. So the eigenvectors of A transpose A is A transpose A minus lambda I into X equal to 0. Subtract minus lambda from the matrix A transpose A. What is X here? Eigenvector. So x1, x2, x3, because this is 3 by 3 matrix. Okay. Now put lambda equal to 25. If you put lambda equal to 25, we get this kind of matrices. So apply cross multiplication method, we get 0, 0, 0. If we get 0, 0, 0 like this, so we have to take only one row. So I am going to take only first row here. Right? X1 equal to 0, 0, which is impossible. So choose one equation. Take the first equation. Minus 12 into x1 plus 12 into x2 plus 2 into x3 equal to 0. We can assume any number for x1 and x2. So put x1 equal to 1, x2 equal to 1. Therefore, what happens if you put x1 equal to 1, x2 equal to 1, 12, 12 cancelled. So x3 equal to 0. Therefore, the eigenvector is 1, 1, 0. Right now, next step is normalized eigenvector. What is its modulus? Square root of 1 square plus 1 square plus 0 square equal to root of 1 plus 1, 0 equal to root 2. So divide each element by root 2, 1 by root 2, 1 by root 2, 0. 0 by root is 0. Okay, is the way to find first eigenvector. To find the second eigenvector, put lambda equal to 9. We get this matrix. Right, now apply cross multiplication, just arrange like 4, 12, 2, 4. Okay, then 12, 4 minus 2, 12. Right, after simplification, we get x2 equal to 1 minus 1, 4. Its normalized eigenvector is 1 by root 8 minus 1 by root 8, 4 by root 18. Okay, next eigenvector corresponding to last eigenvalue, lambda equal to 0. If you put lambda equal to 0, we get this matrix. Okay. After cross multiplication and simplification, we get x3 equal to minus 2, 2, 1. Okay. Its normalized eigenvector is minus 2 by 3, 2 by 3, 1 by 3. Because its modulus is square root of minus 2 square plus 2 square plus 1 square. That is 4 plus 4 plus 1 is root 9 equal to 3. Okay. Therefore, what is V? It is arrangement of eigenvectors of A transpose A. Write all the elements like this. Okay, take its transpose. What is B transpose? Simply change the rows into columns of B. Okay, now we have to construct sigma. What is sigma? Sigma is a diagonal matrix. Its elements are singular values. What is singular value? Simply square root of eigenvalues. So we have two eigenvalues here. We have actually three eigenvalues, but for first matrix we have only two eigenvalues. One is 25 and another one is 9. Okay, taking its square root become 5 and 3. Therefore, sigma 1 equal to 5, sigma 2 equal to 3. Okay, therefore the diagonal value, the diagonal matrix sigma equal to 5. So next entry is 3. That's all. Okay. So here care should be taken. Okay. So the order of sigma must be same as the given matrix. The given matrix 3, 2, 2, 2, 3 minus 2. Okay. The order of given matrix is 2 rows, 3 columns. So it must be 2 rows, 3 columns. Okay. So we take only 2 rows, 3 columns. It's diagonal matrix 5, 0, 0, 0, 3, 0. Again 0. That's all. Okay. Now what is A? A can be written like this: U into sigma V transpose. That is U equal to this matrix, and if sigma is the diagonal matrix 5, 0, 0, 0, 3, 0, and V transpose is this transpose matrix. Put here, if you multiply all the three matrices, we get the same matrix. Given matrix. Okay, is the singular value decomposition of a rectangular matrix. Okay.